Hey everyone, today we're going to be working through a conceptual freefall physics problem. We'll be working with variables only, learning how to set up equations and solve for one variable algebraically based on our context. Learning to become comfortable working with variables just like numbers is an important skill that will likely be tested in your physics class and on an AP Physics 1 exam. Let's look at the question. A ball is thrown straight upwards from the ground with an initial speed v0. It rises, reaches its highest point, and then falls back to the ground. Neglect air resistance. So these are the equations, your kinematics formulas, that you should be given on an equation sheet, so you will likely not need to memorize them. This question only involves movement in the y direction because the ball is thrown straight upwards and then simply falls back down. And the only force acting on the ball is gravity because it's in free fall, so the acceleration equals negative 9.8 meters per second squared. Since we are making the acceleration negative, that means the downward direction is negative and the upward direction is positive. Part A. Write an expression for the maximum height, h max, the ball reaches in terms of v0 and g. G is the constant that represents the acceleration due to gravity. So we will use that instead of the 9.8 meters per second squared. An important thing to think about for this question is the speed of the ball when it reaches its max height. When it's at its max height, the ball's speed is 0 meters per second. So that's an important piece of information to write down. We also know that at the start, the ball was at the ground. So the entire distance the ball will travel, or our delta x, is going to be h max because it goes from 0 to h max. v0 was given to us in the initial problem. It was just v0, and we know that a equals negative g. So we have to find an equation that relates all the variables that we know. So we know v, we know delta x, v0, and a, and we're solving for h max. The equation that we're going to be able to use is v squared equals v initial squared plus 2a delta x. So let's substitute what we know. We know v is 0, v0 or v initial just remains v initial, a is negative g, and delta x is h max. Now, the question is asking us to write an expression for h max, so let's go ahead and solve for h max. We're going to subtract v0 squared from both sides. And then divide negative 2 times g from both sides. And we are left with h max equals v initial squared over 2 times the acceleration due to gravity. Our answer is in terms of v initial and g, so we are good to go. For part B, the question asks, write an expression for the total time t the ball is in the air before returning to the ground in terms of v0 and g. The biggest thing to know for this question is that free fall is symmetric. And what that means is the time it takes for the ball to reach its max height is the exact same time it takes for the ball to return back to its starting point from the max height. Thus, if we are able to find the time that it takes to reach its max height, we will be able to just double it and solve for the total time the ball is in the air. So let's write down what we know about this scenario. We know that at h max, v of the ball is 0 meters per second. We also know that v initial was just given to us as v initial. The acceleration of the ball is negative g. And the time it takes to reach h max is 1/2 t, where t is the total time the ball is in the air. Now, based on these variables, we know we want to solve for time. We want to solve for this t. So we need to find an equation that relates all the variables we know. We will be using this equation. V equals v0 plus at. Let's substitute what we know now. We know that v is 0, v0 remains v0, a is negative g, and instead of t, we're going to write 1/2 t. Let's solve for t now. So we're going to move g times 1/2 t. We're going to add that to both sides. And we're going to get g times 1/2 of t equals v initial. And then we're just going to multiply both sides of the equation by 2 over g. So we get that t equals 2 v initial over g. And now we have solved for the total time t the ball is in the air. In part C, the question asks us, what is the velocity of the ball when it is halfway up at 1/2 h max? Express it in terms of v initial only. So we know our delta x, the distance traveled, is going to be 1/2 h max. And we can use information from the previous question, part A, because we solved for h max. So let's also substitute h max and get it in terms of v0 and g. It was v0 squared over 2g, so this is going to simplify to v0 squared over 4g. Now, we also know that v0 was just v0. We are solving for v, and we know our acceleration is negative g because we're in free fall. We need to find an equation that will relate these variables and allow us to solve for v. And that will be the exact same equation we used in part A. So v squared equals v initial squared plus 2 times acceleration times delta x. So let's substitute what we know. We don't know v squared. V initial is just v initial. Acceleration is negative g. And delta x is v initial squared over 4g. Now the g's are going to cancel. This 2 and this 4 will simplify to a 2 on the bottom. So we get that v squared equals v initial squared minus v initial squared over 2. And that simplifies to v squared equaling v0 squared over 2. Now when we take the square root of both sides, we will get that v equals v0 over the square root of 2. Thank you so much for watching.